Right, here's problem number 2. A ship travels 25 miles due west, then changes direction at a bearing of north something west. Okay, so let's start with a ship travels due west. Again, I like drawing my compass. So north, east, southwest. And due west is directly west, so it's moving in this direction, directly west. And 25 miles. Then it changes directions at a bearing of north something west. So we know it's going in this direction here, northwest. And then when the ship has traveled 45 miles at this heading, it is now 62 miles from its point of departure. So 62 miles is here. Now our goal is we want to find the bearing from point B to C. So let's label what we know. Here is A, B, C. We want to find the bearing of B to C. And again, that's going to be from the north-south line. So let me draw a line here. Bearing is always towards that north-south line or the y-axis. And so we're only interested in this angle here. But if we find angle B, that'll be pretty fast to find. So let us solve for angle B. We're given 3 sides, so we're needing to use law of cosines. And so let's use cosine B. So we need to find B, and that's going to be a squared plus c squared minus b squared over 2 times ac. So let's label our sides. C is opposite of angle C, A is opposite of angle A, and B is opposite of angle B. And let's fill it in. Cosine of B is 45 squared plus 25 squared minus 6 squared, all over 2 times 45 times 25. Okay, and then you plug it all in your calculator and you'll find, so remember you're going to have to use the inverse of cosine once you once you plug all of this in, to be cosine inverse of what you figure out what that is, and when you plug it in your calculator, and you'll find that B is approximately 122.05 degrees. So angle B is 122.05 degrees, this entire angle here. So this is 90 degrees, and so to find the bearing, or what we need right in here, we're going to do 90 from that 122.05. So subtract 90 degrees, and you'll find that's approximately 32.05 degrees. And then to describe bearing, it's going in this direction here. We know it's northwest, right? But looking at your compass, it's going in northwest direction. So it is north 32.05 degrees west. Let's also look at problem number 4. So 2 planes leave an airport at approximately the same time. One flies 425 miles per hour at a bearing of north 5 degrees west. So let me draw my compass. So north, east, south, west. So north 5 degrees west here. So it's 5 degrees. And then 425 miles per hour. Then the other plane flies 530 miles per hour at a bearing of north 67 degrees east. So northeast, let's draw the direction here. And the angle is 67 degrees, and that is at a rate of 530 miles per hour, or I could say mph. So we drew our graphical representation of that, a visual representation. And now we need to determine the distance between the planes after they fly for 2 hours. So we're trying to find this distance here. So I'm going to call that C. So here's C, and then it doesn't matter, I'll call that A and B. So we need to look at a couple things. So it says the distance between the planes after they fly for 2 hours. Now we know they fly at a rate of 425 miles per hour for each, and so we're going to have to multiply that by 2 first in order to find each of these lengths for A and B. So A is going to be 2 times 425, which is 850 miles. And then B, that'll be 1,060 miles. And so we have side, angle, side. We could use law of cosines for this problem. We need to find distance c here. So it's going to be c squared equals a squared plus b squared minus 2 times ab cosine of c. And then I am going to have to square root it. So just to remind myself to do that, I am going to plug it in now. So this is 850 squared plus 1060 squared minus 2 times 850 times 1060 minus 2 times 850 times 1060 cosine of, and then C is 67 plus 5, right? So the entire angle there is 67 plus 5, which is 72 degrees. Then you plug it all in your calculator, make sure you take the square root of the end. You will find that the planes are going to be 1,135.5 miles apart after 2 hours.